All right, so here's a video for Math 1000 on 11.1, and this is the fundamental counting principle. So we're moving on to probability and being able to add up the number of something to think through probability. Okay, so the fundamental counting principle is where you is used, to determine the number of possible outcomes in a situation, and you're going to times the outcomes together. Okay, and that definition's at the bottom, but I want to show an example of why this works and the logic behind it, and that will help you to remember when to use it. Okay, so here's my scenario. For breakfast this morning, I wanted fruit and yogurt, and I had to decide what flavor I was in the mood for. I had low fat, plain yogurt and regular vanilla yogurt in the fridge. I had bananas, strawberries, and blueberries in a drawer. If I feel picky and I want one yogurt and one fruit, how many choices do I have for breakfast? So I want to show this in a tree diagram because this is a good way to think through a lot of problems that you might get stuck on. So I'm going to think through, all right, so my first choice has two options. That's either plain or vanilla yogurt. So I had two options, so I have two branches. So no matter what I pick, I still can pick any of the three fruits. So there were three fruits that I could pick from after I picked my plain yogurt. I could pick banana. I could pick a strawberry, or I could pick a blueberry. Now, I could pick plain in all three, but it's the same as I could have picked vanilla and I still could have had the banana. That almost looks like it has double ends. Oh well. Strawberry or blueberry. So either way, if I pick plain or I pick vanilla, I can pick those fruits. So my total choices is you add up how many you have. 1, 2, 3, 4, 5, 6. So there's 6 total choices for breakfast. So I love the idea of a tree, but what if I have 20 different flavors of yogurt and 15 different fruits on hand? It's way too big of a tree diagram. So the tree diagram is great, but that's what brings in this fundamental counting principle. And that's what I put down here. What if you have more than two things you're choosing? What if you have a lot more? So that's the idea of multiplying your choices together. So the counting principle is used to figure out the total number of outcomes of something, and you multiply the choices. So for this example, I would have 2 choices for yogurt and 3 choices for fruit, and that would give me 6 total choices. And that's the same answer we got from our tree diagram. Okay, so counting principle, multiply your choices together. That's what we're doing in this section. So this first example here, the Greasy Spoon, it's really our second, that's okay. The Greasy Spoon restaurant offers 6 appetizers and 14 main courses. In how many ways can a person order a 2-course meal? All right, so I could do a tree diagram, but it would need 6 branches, then 14 on each of the 6. No thanks. So I could use, there's 6 choices for the first one, 14 choices for the second. That is a total of 84 when I multiply them. So there's 40 or 84 2-course meals. Okay, so there's 84 2-course meals, excuse me. Okay, is this in this semester, problem 2, in this semester, you will take your required psychology and social science courses. Because you decide to register early, there are 15 different sections of psychology for you to choose from. Furthermore, there are 9 sections of social sciences available that don't conflict with your psychology class. In how many ways can you create 2 course schedules that satisfy this requirement? So how many choices do you have for the first class? 15. So I take 15 choices for the first one. And how many do you have for the second class? 9. Definitely a bigger school than Sheridan College. So 15 times 9 is 135. So there are 135 ways for you to pick your schedule. I don't think you would ever have 15 sections. Maybe I was trying to think when I was at, I'm wearing it too, by Boise State where I went to college. Trying to think if I had that. Okay, so there are 135 total options for that classes. Okay. Okay, number 3. I don't know why I put this in here, but it could be more than 2 options is where I'm going from this. So right now we were just looking at 2 things. We had a 2-course meal. We had 2 courses. You could do it for 20 courses. You could do it for however many things you want. So number 3, next semester, you're planning to take 3 courses, math, English, and humanities. There are 8 math, 5 and 4. So now they're adding more than just 2. So there's 3. You just multiply them. So this one's 8 sections of math, 5 of English, and 4 humanities that you are interested in. So how many ways can you organize your classes? 8 for the first, 5 for the second, 4 for the third, and you multiply to get 160 different possible schedules. So you can see how it's helpful to do this because there really are a lot of options for some things that you think, oh my goodness, there's only 4 different options. Well, or there's, look at, especially like some of the menus. I only have 4 different these and 3 of these. And really you have quite a few options, but okay. Number 4, a car manufacturer are now experimenting with lightweight 3-wheel cars. They are designed for one person and considered ideal for city driving. Intrigued? Suppose you could order such a car with a choice of 9 possible colors, with or without air conditioning, electric or gas powered, and with or without an onboard computer. And how many ways can you order this car, right? Okay, so let's look at our first thing is colors. How many colors are there? 9. Okay, timesing that by with or without air conditioning. How many choices is that? With or without? 2. So this is our AC here. And then the next one's electric or gas powered. So electric or gas, that's 2 choices as well. And computer or not computer, that'd be kind of cool. Computer in the car, excuse me. So 2 choices again for that, computer or no computer. And that was our only choices. Yeah. So 9 times 2 times 2 times 2 is 72 different ways to order my car. All right. So the next couple are a little trickier, but I think I like them. You're going to take a multiple choice test, but you didn't study. So how many options are there really for you to choose from? This so leads into probability. So each of the questions has 4 answer choices. So A, B, C, D, with 1 correct answer per question. If you select one of the 4 choices for each question out of 10 questions, how many ways can you answer questions on your test? So you right now have 10 questions. So you can think of it as I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are my 10 questions. And how many choices do I have for the first question? 4, A, B, C, D. Times it by how many choices do I have for the second question? 4. Now I could have mixed it up. That's why I did the slashes just to kind of show. but we really only have 4 on each of these. I should have 10. Okay, what's that the same as? 4 to the 10th. And I like 4 to the 10th on my calculator versus 4 times 4 times 4 times 4 times 4. So 4 to the 10th power is 1,048,576. So 10 questions, and you had 4 choices. Here is how many different ways you could answer that. And now this is where we're headed, but I love this idea because I'm just silly like that. Only one of those is the right answer. So you would have a probability of 1 over this. So 1 divided by that last answer is 0.0000060's chance of getting 100%. So here's where I'm going with that. Multiple choice tests aren't that easy. If you don't know the material, if you are guessing, it's just not very likely that you're going to get even 1 right. Crazy, huh? Okay, hopefully that helps you think, man, I should really study even if it's a multiple choice question test. But that all this is asking for is the total outcomes, not the probability yet. So the telephone numbers in the United States begin with a 3-digit area code followed by 7 different digits for a local phone number. Area codes and local phone numbers cannot begin with 0 and 1. How many different phone numbers are possible? So 0 used to be how you called the operator to like, there used to be operators like you could call them and get like somebody's phone number, or can you call this person for me? And I don't know, it's crazy, but that was, even in my lifetime, that was the thing. And 1 is how you get out to a long distance call. That used to be a thing as well. You don't really have to dial 1 anymore, or so we don't have an operator at 0 either, but we're just going to go with it. So we know that you start with 3 numbers slash, then 3 numbers slash, then 4 numbers. So let's think of how many options we have for each digit. So how many numbers do we have that you could type in? Well, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, no. There's 10, right? I said 10 weird, but 10, right? Because 0 is 1. So we are counting base 10 because we have 10 numbers, because 0 is a number. So we count in base 10. That's how our number system works. Each time we get more than 10, we roll over to the next category, right? So you'd roll into the teens or the 20s or the 30s or the 40s. Teens. Yeah, that too. Okay, so we can't have 0 or 1, but there's 10 options. That leaves 8 other numbers that you could use for that spot. Now, were we restricted here or here? No. So we could use all 10 here, all 10 here. And again, we're just using these little slashes to help us organize our numbers. Now, it said you cannot begin your phone number with 0 or 1 either. So there's only 8 choices here as well, because you couldn't have 0 or 1. And this is true. And then we could have 10 choices for all other spots. And these are our choices. So then we times our choices together to get our total possible outcomes. So if I times this together, 8 times 8, 64, and then 1, 2, 3, 4, 5, 6, 7, 8 zeros. If you put that in your calculator, I'm going to show that to you. It's going to put it in scientific notation. So I have 8 times 8 times 10 to the what power? 1, 2, 3, 4, 5, 6, 7. There's 8 of those. So here is our number that we had. Oh, it didn't put that one in scientific notation. Okay, if it did, you just have to move the decimal. How many places? So watch, I'll just times this by 20. So it is, there we go. This isn't an answer to anything. If it says something like this, it's telling you E after this E, move the decimal 11 places. So here's the decimal, move it 11 places and add zeros in. Okay, if it would have been negative, it would have been a decimal to the left. All right, so that was my last question. Man, that's a lot. A lot. I kind of feel like I want one that counts down a little bit. What if man, I can't think of one off the top of my head. Let me look at my note packet real quick and see if I can think of one. Let's see if any of these count down. I could think of it as like, oh, this is my other notes. Shoot, guys, I can't think of one that counts down off the top of my head. What if it was like, here's what I'm thinking of. So this is problem 7. What if you had 5 seats up front? Or no, let's think of this, 5 places to place at a race. No, that's not going to work. No, you could do that. You have 5 people. How many ways can they place? So if I have 5 people, we're all running. How many different ways can they place? So let's think of first, they can be second, third, fourth, or fifth. Right? Those are the options. How many ways, if we're talking about racers, how many of them could get first place? 5. All 5 have that all 5 could get first place. But if someone is first place, now how many options do you have for second place? 4, because 1 person has to be first place. We don't know who, but then we have 4 for here, and then we'd have 3, and then 2, and then 1, because somebody has to get. So that idea of counting down is important if you need to leave one behind each time. So this would be 120 total ways for them to place at that race for 5 people in 5 places. Now, if we would have had 10 people and 5 places, it would have gone 10, 9, 8, 7, 6, 5. And you would have ran out of places some people wouldn't place. Okay, so they wouldn't be included in your time thing. So I wanted to add one that counts down. We're not done with this idea. 11, 2, and 3 are the same idea. And we're going to do both of those on Wednesday as long as I'm back. All right. Talk to you guys later.